Jain everybody. Today we would be discussing the next topic, that is how we can generate the digital tokens or the digital coin which take part in the blockchain transactions. So first of all, we have discussed about what do we mean by asymmetric encryption. We have discussed about asymmetric encryption, and in that asymmetric, we have discussed we have to generate two keys. One is the private key and another is the public key. Private key is the key which was used to identify the person who is sending or identify the sender. So this private key is used for authentication of the person. That is, for example, when we are giving a check to one of my friend, then if that particular friend takes the check to the bank, then bank verifies that particular signature. That is authenticating that I am only the owner of that particular account. Similarly, when we are having this in the form of the digital, how we can authenticate? That is through this public key. And when we want that this particular public key, obviously if this is my digital signature, I should know it. I should have a copyright of that. So public key and the private key, as we have seen in asymmetric encryption, we generate them simultaneously. Okay. Public key is being distributed to each and every person who is involved in that particular blockchain or who is involved in that particular network. So that is similar to your mail ID, that your mail ID is known by each and every person. And the private key acts as the private key is acting as the digital signature or for authentication, that you are only the user who is sending this particular information or who is sharing or generating this particular digital token or the coin. So for generating the digital coin, we should have one unique ID for that particular coin. So this is the coin ID which is unique for each and every coin or the token which we are generating to initiate that particular transaction. Assume that I have generated a coin and that coin has a worth of rupees 500. Okay, so on generating this particular coin, I have generated two keys. One is the public key and another is the private key. Okay, so this public key is being given to each and every person who is involved in this particular network. If I am the own distributor, then this is the person I. So I have distributed my public key, that would be denoted by PUK, and the private key by PK. I have to keep it myself. That is authentifying me that I am the valid user who is sending this. So whenever you are generating that particular coin, assume that I have to purchase a book. I have generated this particular coin and I have to purchase a book, and I have to purchase the book from my friend. So I have to give this digital coin to my friend so that I can exchange it in terms of the book. So I have to sign this particular coin, this unique coin ID, after creating it with my public key, so that the receiver can identify that I am the owner of this particular coin. So after checking that particular coin, it checks that if it is being signed by me, means that coin is a valid coin. So in first step, I have to generate a coin ID, then simultaneously we would be generating a public key and a private key. Then for authentication, I am signing this particular coin with my private key. Anybody who is having my public key can decode or decrypt this particular code and verify that if this coin is valid or not. How? Because we have that synonym. For example, if I tell you that this is a very simple example which I am taking, this practically doesn't exist in the system. If I tell you that I have to generate public and private key at a combination that their sum becomes 10. So I can have one combination that my private key is 5.6 and my public key becomes 4.4. This gives me a sum of 10, or I can have 3.9 and 6.1. So you can have any of the combination. Those who have my public key can only do it because this sum has to be equal to 10. Okay, so if I'm encrypting it by 5.6, then it would be decrypted by 4.4 only for verifying that I am the authenticate user who has given this particular coin. So after generating this coin, we have created the coin, I have signed this, now I would be giving it to my friend in exchange of that particular book. Okay, so I have to exchange this for a book. Now to buy a book from the friend, what I have to do, I have to tell that particular friend that I want to purchase a book. So obviously I have to tell that friend that it is intended for you. Whenever you are writing a check, in that particular check, the digital sign is mine. So that is being authorizing that I am the owner of that particular account. But to whom you are giving it, you write in that particular pay to option. That is, if I have to give to my friend, then my friend should know that it is intended for that particular user. So obviously, while doing that, you have to sign it by the public key of your friend. Public key of the friend, so that only the private key of that particular friend would be able to decrypt this. This tells you, here I am doing authentication, that I am the user, and here you are authorizing, that is, it is specifically intended for the friend. When that particular friend receives this particular option that you have signed it, so you are signing it, why? See, you have created a coin, then you have signed it. So that is आपका money है. Then you have to again sign by your private key for this signature in your check. I'm making an analogy that is signature in the check which you are doing it. And here for PUK, that the public key of the friend is what you fill in pay to option. I have to pay to, so assume I have to pay to Aman. So that is the person to whom I have to pay. So here this Aman is the name of that particular person. But here when we are doing in the form of the digital, how we will do it? We will encrypt along with my private key with the public key of my friend or the Aman, so that he knows that this particular digital coin now is being intended for him and it has been given by me. Okay, so you have to check this particular transaction. So now here I am doing authorization. Authenticity is being done by signing it by private key, and authorization to whom we are sending it is given by the public key of that particular person. So now this particular link, see this particular red link, we have created a hash function here when we were encrypting this particular function by the public key. While I was encrypting with the public key of the friend, I have generated a hash. In the last videos, we have discussed hash is a fixed size code which is being generated. I think we have discussed that we have an SHA algorithm which we usually use of SHA 256. That is, it generates a 256-bit fixed length code or 64 characters code, and that particular character code is sent to the friend in the form of hash. So here H denotes the hash, and the link which is being denoted here gives you the history. Who has created this particular coin? Who was the owner of this particular coin? So this is how that particular physical transactions are being converted into the digital transaction. First, who has created this coin? Who is the creator of the coin? So here for creator, you should have a private key encryption. Then who is sending you? Again, the private key of the person who is sending you, and public key to whom you are sending. Okay. So here we are answering few things. That is, I am answering the questions here as first, here I am answering who created it. So who created is being done by, signed by private key of that particular person. Then who is sending it? Who is the sender? Is being done by this. And who is the receiver? Who is the receiver is denoted by this. The creator and the sender can obviously be different. We don't generate the money. We don't generate the physical money, the note which we spend the physical hard money. We don't generate. RBI generates, or I should say the banknote press generates. It goes to the RBI and then RBI distributes it. So we cannot always be the creator or the generator of that particular coin. Now that particular coin has went to my friend, and he is now owning that particular coin because he has decrypted that coin, and this tells the history ki kisne generate kiya, who generated it, who was authorized to give, who was authorized that this money should be, or the digital coin should be transferred. Now, this particular friend wants to get it exchanged because I have exchanged it in the terms of buying a book. Now, because he was a bookseller, he want to purchase the book in lump sum from some another person, and say that particular person is Arvind. So he has to pay that money to Arvind. He has a digital coin which was created by me. So this was the creation of the digital coin. Now this was first owner. Owner was first owner. Now the second owner becomes your friend, or the bookshop person who has now that particular digital coin. So he want to give this to the wholesaler book person. I have named that as Arvind, and now he has to give that digital coin to Arvind. So while he want to give this digital coin to Arvind, what he has to do? He has to encrypt this particular digital coin with his private key. Okay, so this owner too has to sign it by his private key, and then he has to encrypt it by owner 3's, this is to owner 3's public key, that is the Arvind's public key. So whenever we are doing it, we should know the public address of the Arvind, then only we would be able to do it. So as I told, we are generating public key and the private key simultaneously. Private key is being kept with us and the public is distributed to all the nodes which are connected in that particular blockchain network. Okay. Here again you can see one more hash value is being generated. This hash value or this hash function, or one more red arrow, that shows that previously this was created by me. Then after me, the owner became the bookshop person or my friend. Then from that friend, now the owner becomes Arvind. So this tells you history of all those particular transaction or the person who owned that particular coin previously. Along with, see, starting from the creation, then the first owner, then the second owner, now the Arvind is the third owner. So we know all the history of this particular coin. How tampering cannot be done into this? First, because while I am the owner or I am the creator, I am signing it with my private key. So whenever this Arvind checks this particular transaction history, he would see who has sent him. So he can see it by the private key of that particular person, who is the person who is sending him. So the friend Aman is the person who is sending him. So after receiving from Aman, who gave it to Aman? Okay, so now who gave it to Aman? Because here the Aman would be coming. Here I have Arvind, and now Rashmi was the owner, which was having that particular money. And who created it? Again, Rashmi created it. So first the coin was created by Rashmi, then Rashmi transferred it to Aman, then Aman transferred it to Arvind. So we can have this particular history of this digital coin or the blockchain token which is being created, how it is being transferred from one person to another. So this is when we are doing, or when we are encrypting it with the public key, we are telling for whom that particular intended coin is or the token is for. And when we are encrypting by the private key, that tells who is the authorized person or the digital signature of that particular person is taken into account. See, if I now in this final statement, the owner was the third person, that was the Arvind. Now assume I have something going on into my mind, and now I tell you that I have created this particular coin. I was the owner, and I want to spend this particular. We have created this for rupees 500. Okay. Now using the same coin ID, if I want that I should give this particular coin to some another person also. Say, because I have told Rashmi was the creator, then I gave it to Aman, and then Aman gave it to Arvind. This is for digital coins or the tokens. So I have this particular coin ID and I can give it to anybody else also. So now I decided that I should give to Ramesh. The same coin, I'm giving this to another person because I was the owner, and something something fuzzy is going on into my mind, and I thought that I can reuse that particular money, which we cannot do in terms of the physical money. But in the case of this digital money or the digital token, we can do it. And when I'm spending the same coin ID for purchasing one more book from Ramesh, then this particular attack is called as double spending attack. When we are having this particular physical monetary system, once I have a 500 rupee note and I'm given to the shopkeeper, I don't have that particular, I am not owner of that 500 rupee note again. But in case of the digital coin, I still have that particular coin ID, the private key, which because I was the creator, I have that money. But in physical, we don't have it. So in physical transactions or physical monetary system, we cannot have this double spending attack. But in all these digital transactions, we can have this double spending attack when we are the creator or we are the owner. So I'm spending this particular, I'm giving the same coin or the same token to two different persons. This is called as double spending attack. See, so I was the creator of this particular coin, and then I have given it to Aman. Okay, this is Rashmi, and then Aman has given it to Arvind. Now again, when you are giving it this to another person, then this particular, you may not be the culprit, maybe one of your friend who owned that particular thing, Aman has given it to another friend, that is Ravi. So Aman has now given it to Ravi. In this particular case, now who is the owner? If you have the same coin ID which was owned by this Aman after the first transaction, and he has spent it twice, one he has given to Arvind and one he has given to Ravi. So now practically, who is the actual owner of this particular coin? It is Ravi or Arvind. So it's a bit confusing. We have to solve this particular problem. So this is double spending. We cannot only do it for two. I can sell the same particular transaction to Manu also. So Aman is the person who has given this to one more person, and that is also having this history. So you can spend the same coin thrice, 4 times, 5 times or 10 times, unless and until that particular forgery is being detected by anybody else. Till then you can do that the same amount. So we have to stop this particular double spending attack. This is named as double spending attack. It can be done in 3, 4, 5 times. So if you can do a double spending, that is, you are spending the same coin value twice. So this is called as the double spending attack, and we have to overcome this attack in blockchain. So we can do this by keeping a proof of digital currency. That is, we have to keep a history of all those particular transactions which is being created from the first who has created that particular coin to the current owner. And after doing that, we should just know where that particular link is going on. See, if this is the particular hash key which I am receiving, I am keeping that this is transaction ID 73. What was the previous value? Using that previous hash value, I'm going to transaction 72. And then again, using this particular previous hash value, I'm going to transaction 71. So we are keeping a transaction history tracking system. In this particular transaction history tracking system, we can finally create a coin which cannot be tampered or which cannot be reused. Tampering is we cannot change that particular values, or we cannot reuse that particular data. So one thing is, we don't want to change that particular data, and second, we don't want to reuse that particular data. So for reusing that particular coin ID. So for this we have to create a coin which keeps a transaction history tracking system. So we have to track each and every owner, at each and every point, who was the owner, to whom it belonged, who was the owner, and who gave it to that particular person. So this is how we keep this particular. We have a previous hash value. See, always we have a previous hash value which is pointing to the previous box which is being denoted here. So whenever we have this particular, so whenever we are creating this, we see what is the coin ID, who was the with coin ID 73, who are different owners, what are the transactions which were valid. So this particular structure of the coin ID helps us in not spending that particular coin twice, thrice, or in number of times. So what all things we are getting? The number of transaction, first is who created it, so number of transaction is 0. The first transaction in which it was done, what was the value for this, okay, and who was the recipient. Obviously the who was the recipient means who got that particular with encrypting the public key. And here we have this particular transaction ID also, and what was the type of that particular transaction. If you are exchanging in terms of a book, if you are creating that particular coin, if you are spending in term of some food article which you are purchasing, anything can be that. So we have to keep a track of this particular history. Now the question comes, who keeps a history of this? Whenever we need, I create a new coin and then I consume it or I destroy it. So who is taking care of this particular thing? So we should have a database, or we should have, as we have discussed in the last videos, that in blockchain each and every person has a public ledger. So we cannot create our own coin and we cannot delete our or destroy our own coin, because each and every person has that particular entry. So we have to validate who has consumed the coin. If the coin is being consumed, was that coin valid? There are two things. Consumed coin, we have to see if it is valid or not. If the coin is invalid means maybe that amount is more or maybe the amount is less. I want to spend for 550 rupees and the coin was having only 500 rupees. Or maybe I have spent that particular coin previously also and now I am retrying to do it. So in that particular case, we should know if you have already consumed, or if you have not already consumed, then only we can have a valid transaction. Otherwise, if I have consumed that particular coin previously, then that particular coin won't be valid. So for validity, we have to see the coin which we are consuming is a valid coin, then it has not already been consumed, and the total value in and total value out should be the same. That is, I told you I have created a coin with rupees 500 and now I want to spend rupees 550. So this is more money. So I cannot spend this coin. I have to spend some another coin. And then we have to see who were the owners of that particular coins. So for keeping this particular transactions, we have to see who were the previous owners. So this can be done by this keeping the track history. Okay, so to check that we are not double spending, we should have a combination of the public key and the private key, and we have to track each and every transaction which is being done. So we have a series, like in the last video we have told that we have this particular blockchain as linked list data structure. See, you can have a form, the same structure is replicated, duplicated, and we have a link with this particular data. So this linking tells that we have a linked list data structure. So coming to the end, that we should generate the digital coin, sign it by the public key for authenticity, sign it by private key for authenticity, that acts as a digital signature, then sign it with the authorization of the public key of the receiver who is receiving it, so that we can keep a track of all the transactions which is being done in that particular block. Thank you for this video. In next video, we would be discussing the components of the blockchain system.